Hello and welcome to lesson 4.2. So in 4.2, we're going to introduce the quadratic formula. Many of y'all remember that from high school, but hopefully we'll give you a better feeling for it here or a little bit of a deeper understanding. So I think a really good place to start is what is the quadratic formula, or maybe better yet, where does it come from? So if you were to take a lot of time and I were to give you ax squared plus bx plus c like we did last class, where these are going to be some sort of numbers, and you were to spend a very long time completing the square and working your tail off to solve for x, you would get two solutions. Okay? You would get negative b plus the square root of b squared minus 4 times a times c, or 4ac, all divided by 2 times a. And the other solution you would get would only have one slight difference. Instead of adding the square root, you would be subtracting. So minus b minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And so there would be your two solutions for this thing. Now, when is this extremely useful? This is extremely useful for when you can't factor this and you want to solve it. This needs to be set equal to 0, so it's something solvable. You can't solve it. Maybe you don't want to complete the square. You'd get the same answers if you did complete the square, but this gives us another way of solving these things, okay? All right, cool. Well, this is just a plug and chug method then, where all I'm going to do is look at what numbers are in front of the x squared, in front of the x, and over here by itself, the last term. And I'm going to plug them into these spots and just use the calculator or use my own skill at multiplying and stuff to find my two solutions. So let's dive right into an example. So let's say I have an example like this. 3x squared plus 16x plus 5 equals 0. I don't know about you, but I have the feeling this probably doesn't factor. Maybe I don't want to complete the square because I'm going to have something kind of nasty there. So let's go ahead and just use the quadratic formula to solve this. So maybe it might help you if you label your pieces. There's my A. That's my B. I will give the tip to always pay attention to the sign directly in front of it because that belongs to that coefficient. And this is my C. So there's my A, B, and C. And so if you don't have the formula, I would suggest you maybe practice writing it down each time to start getting it cemented in your head. I have it memorized, so I'm going to jump right into finding these solutions for X. And so negative B, so the opposite of positive 16 is negative 16. We'll do the plus square root one first. Square root B squared, so 16 squared minus 4 times A, which is 3, times C, which is 5, all divided by 2 times A, which is 3. Now, we're going to do this same exact thing. I guess I might, so I don't have to waste a bunch of time, write this same thing over again for the other solution, but instead of adding, we're just going to have a subtraction. Okay, so what I may do is lazily just copy and paste it. Control copy, control paste. So there's our two. Oh, let me fix this though. These will be our two. Make sure this is the littlest one so I don't erase everything. These will be our two solutions. Okay, so now all I have to do is spend the time figuring out what these things, um, what they come to. Oops, didn't mean to open up that. All right, now, we can get to work on this sum. Let's see. I know 2 times 3 is 6. 4 times 3 times 5. I think we can handle that. 16 squared. Does anybody know there's 16 timetables? I happen not to know my 16 timetables. So we'll maybe use a calculator to figure out 16 squared. 2 times 3 is 6. So something, actually, I think I know 16 squared, but not to be like wrong, let's actually go and just try a calculator. Like I said last time, if you just Google Desmos calculator, there's a scientific calculator, which is pretty good. So I can 16 squared equals 256. Yeah, we should have known that. As a matter of fact, we did know that. So if you use a calculator, 16 squared is 256. 256 minus 4 times 3 times 5. Let's see, 3 times 5 is 15. 15 times 4 is what? That's right, 60. Minus 60. If you didn't know that, we could go into, once again, a graphing calculator, and we could do 4 times 3 times 5 and get 60. It's perfectly okay to use a calculator. Now, if I wanted to do all of this in a calculator, I would still strongly suggest you do it in pieces so that we don't make any mistakes typing anything in. Okay. Now, I'm going to have the same numbers over here, minus 16, except for it's going to be minus the square root of 256 minus 60 divided by 6. Okay. Now, let's see here. What is 256 minus 60? I'm glad you asked. We'll just use calculator. 256 minus 60 is 196. And so I have negative 16 minus the square root of 196 divided by 6. Oh, not minus, plus. And on this side, it's minus 16 minus the square root of 196 divided by 6. Okay. Now, we should try to simplify this or see if 196 is a perfect square. But a lot of the times whenever we actually want to use the quadratic formula, it all depends on kind of the context of whether we want a decimal or something written with the radical expression. So for instance, later in this lesson, we're going to do some examples that I would like, that they're going to be word problem examples, and I want you to round just to like 1 or 2 or 3 decimal places. I'll tell you in the problem. And we're going to use a calculator just to turn that out. Now, 196, so if I go back to my calculator and I'm like, oh my, what's the square root of 196? 196 square rooted. Oops, let me just clear all this out and write it better. Clear, clear, clear. So square root of 196 is 14. That happens to be a perfect square. So wait a second. That means I have a feeling that what I said earlier is not right. This might be factorable, but ignore that for now. This might be factorable then, so I get a square root of 196 is being 14. Oh, someone was really nice to you with the first example is what this means. And so I have negative 16 plus 14 divided by 6. That's one answer. Negative 16 minus 14 divided by 6 is another answer. And let's see, negative 16 plus 14, what's that going to be? That's going to be negative 2 over 6. That'll reduce to negative 1/3. So there's one solution, right? Over here, oops, sloppy equal sign. Negative 16 minus 14, that's going to be negative 30 divided by 6. Oh, that's going to equal negative 5. Guess what? This thing did factor. Sneaky, sneaky. But does anybody know this off the top of their head? No, no one's going to feel confident doing that off the top of their head. But what it would be is like uh, 3x plus 1 and x plus 5. It would factor into that. But anyways, that was intimidating looking. So there's one example to show you something. One, the quadratic formula works. Two, if you're not sure if it factors or not, use the quadratic formula. If it does factor, you'll get those nice answers. If it does not factor, you'll still get the correct answers. They'll just be nasty decimals or have square roots in the answers. Let's do another one that does not factor this time. So the answers will not be pretty like 5 and a third. I'll do another example. This one I will be not as nice giving you one that is factorable, but I also will be nice and not make them huge numbers like that one. So x squared plus 7x plus 4 equals 0. And you say, okay, we can handle this. There's no number out front, so it's understood to be a 1. So that's our A. Positive 7 is our B. And positive 4 is our C. And so we can use the quadratic formula to find these two solutions. So remember, negative B, which happens to be 7. So negative 7 we're going to do plus square root of b squared. We might can go ahead and start to some of these pieces, but I'm going to write it out this time. B squared minus 4 times a, which happens just to be 1, times c, which is 4, all divided by 2 times a, which is just 1. Okay, so this is what x will equal. And then over here, we're going to do the same thing. X will equal, except for instead of a plus right there, it'll be a minus. So negative 7 minus square root of 7 squared minus 4 times 1 times 4. Those are times dots. All divided by 2 times 1. So some of this is easier arithmetic because that was nicer to give smaller numbers. So for instance, I think we know 7 squared is 49. Hey, where'd my plus sign go? And then 4 times 1 times 4, that's just minus 16. 4 times 4 is 16. Divided by 2 times 1 is 2. And over here we'll have the same numbers, negative 7 minus the square root of 49 minus 16 divided by 2. Now, you may not be real confident in your subtracting and say, oh, what's 49 minus 16? Like I said, please feel free to use a calculator. 49 minus 16, but that's not very hard. That's just 33. Now, oh, went too far. And so what we're going to have is negative 7 plus the square root of, this part is 33. Now, 33 is not a perfect square. This didn't end up being beautiful like last time. Well, that's because this one is not factorable. And the answers are not going to be pretty numbers. Now, does this simplify anymore? So we need to see if we can simplify the radical part of this, or if the 2 will reduce anything out. Well, for one thing, 7's prime and 7's odd. The 2 is not going to reduce out or divide anything out with that 7. 33. What multiplies to give you 33, whole number-wise, or integer-wise? All I can think of is 3 and 11. Neither of those are perfect squares. There are no perfect squares that divide evenly to 33, so we're finished. So sometimes, if you just want them written with radical expressions like this, we leave them. If I ask you to round, we will put them in the calculator and find the decimal. Actually, what this is called, now you need to know this, these are called the exact, this is the exact solutions. Why are they called exact? Well, because you can type this in your calculator, it's going to be a lot of nasty decimals, right? If I ask you for a decimal, you're going to have to round. Those are rounded answers. The exact ones will have to be written in this way. How do I know that? But when you have something that's not a perfect square underneath the square root, it's going to give you irrational. It's going to give you an irrational number, which means it's going to be a decimal that goes on forever with no repeating patterns, blah, 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 right? And so that you will have to round these somewhere if I ask for a decimal. So if I ask for exact solutions, you have to keep the radical form with the square root symbol, unless this is a perfect square. If I ask for a decimal, you're going to have to round it. That's not exact. Okay? So exact form, we practiced that. Now let's practice some that are going to be non-exact or decimal. Those pop up nicely in word problems. All right. So let's just say that we're looking at a right triangle. What I'm going to attempt to do is draw this as I talk. Not the best artist, but let me give it a shot. Oh, there's a beautiful right triangle. Okay, and let's write down the pieces as we go. Beautiful right triangle. So we're going to need the Pythagorean theorem formula. Does anybody remember what that is? Pythagoras' formula. It says that if you take one of the legs and square it, we call that A. Take the other leg and square it and add those together. It's going to equal the long side, the hypotenuse, squared. Okay? All right? So that's the Pythagorean theorem. So we know that the length of the hypotenuse is 20 inches. So there, this piece is 20. That's the C part. Yay! The shorter leg is not known, so we're going to call that X. Let's just say that's the shorter one. The longer leg is 6 inches longer. Well, than the shorter. Well, if I don't know what the shorter is, it's just X. Well, if it was 10 and I said this is 6 longer, what would you tell me this is? 16. How did you get that? You took the shorter leg and you just added the 6 to it. Okay, well, that's not too bad. Now, find the length of this shorter leg. So find me x. Round your answer to 2 decimal places. Now I have a hint here. Don't read the hint yet. But I think we could work this out. So a squared, let's just call this a. So x squared plus b squared, that'd be this part squared. So x plus 6 squared is equal to this squared, so 20 squared. Now this may take us a little while to sort out and kind of get this written in a form that's easier to work with, but maybe not too long. So I have x squared. Let's see. So if I square this, you take the time to FOIL it out. You might have to write x plus 6 times x plus 6 and go through all those steps. Or you could remember the pattern for a perfect square polynomial. Perfect square here. So this would be x squared plus 12x plus 36 is equal to, now 20 squared, that would be 400. Now, if I combine my like terms here, that's 2x squared. Bring down my plus 12x. And then subtract 400 over. So what's 36 minus 400? That happens to be negative 364. So minus 364. We now are ready to use the quadratic formula to solve this. We have our a, our b, and our c. Notice the c is negative in this case. So we're going to have two solutions, but I would like to talk about both of these in a second. So x will equal, and maybe this time I'll be lazy and do the plus or minus symbol. So opposite of b, I'm going to do both at the same time, plus or minus the square root of b squared minus 4 times a times, and because it's negative, I'm going to put it in parentheses, c, which is negative 364, all divided by 2 times a, which happens to be 2. Whew. Now these are going to be some pretty large numbers happening in here. So why don't we use a calculator to figure this part? 12 squared minus 4 times 2 times negative 364. Okay, so 12 squared minus 4 times, oh, I already forgot the number. What was it? 2 times, we'll put this in parentheses, negative 364. Let's see if it likes that notation. Some of these things don't like when you use a subtraction as a negative. Let's give it a shot. Boom, ends up being 3,056. So the negative and the negative here make this a positive. And we get this really large number, 3,056. Okay, so what we're looking at here is negative 12 plus or minus the square root of, and we use a calculator to find this, 3,056 divided by, I think we can handle 2 times 2 is 4. Okay, so let's see if we can get both answers here. So we're going to do the negative 12 plus this thing and the negative 12 minus this thing and divide by 4. So back to a calculator. So I need the square root of this thing. So we'll go square root of oops, I'm typing in the wrong spot. Oop, I've already messed it up. Let's see, let's go back. All right, square root of, what is it? 3056. Okay, there it is. Notice it's a nasty decimal. Now, this is what's extremely important. Do not chop this off and round it yet. We would like to use our calculator to use this whole thing with all the decimals so that we round only at the end. Because what's going to happen is if you round in your middle steps, you're going to have some rounding error. And as you keep rounding along each step, you're going to have more and more error so that you might be really far off by the end. So save it all for the end. So back to our formula. So negative 12 plus or minus this divided by 4. Okay, so negative 12 plus square root of 3056. And then we're going to need to say all in parentheses divided by 4. Boom. 10.8202. Now, I want, usually in the homeworks, 2 decimal places. So if we round 2 decimal places, 10.82. Okay. So let's write that down. 10.82. Now let's find the other one with the subtraction sign. Okay, so back to our calculator. I think I can go in here and just turn this into a subtraction. And there, negative 16.82. Okay. So those are our two solutions, negative 16.82. But now, what was that hint about? Well, before even reading the hint, these are measurements, right? Can this length be negative 16 inches or centimeters or whatever this is? No. So whenever I do these word problems, quite often, look at your two answers. One will make sense, one will not make sense. Okay? So what we'll need to do is throw out the one that doesn't make sense. I cannot have negative 16 inches over there, or centimeters, or whatever this is in. So my answer is going to be 10.82, okay, inches, 10.82 inches. So the side of this leg, X, is 10.82 inches. Ooh, try to be a little neater. Okay, let's do one more word problem. You'll see one like this on the homework and on the test where you have a Pythagorean theorem to solve, so make sure you know this. One more example, and we'll talk about why this works. So let's say you're on top of a building and you throw a ball downward. Say the building's a 180-foot tall building, and you throw it with an initial velocity of 20 feet per second. The height of the ball will be modeled using this following function. H for height, h of x is equal to negative 16x squared minus 20x plus 180. X is the number of seconds after you let go of the ball. How long will it take the ball to hit the ground? So what we're asking for is how long will it take for it to hit the ground? We're asking for when it has a height of 0. So we'd like to set this thing equal to 0 and solve to see what time, because we're asking how long, what x value, what time it is when it hits the ground. If you want to draw a picture of this, there's you on top of this building, throwing the ball down, and we're looking for when it hits the ground. Now, technically, this is a parabola, if I drew the rest of it. And what we're looking for is one of these where it crosses the x-axis. Okay. Now, you don't have to know all that terminology. It's really good to relate it all. But all we're looking for is when it hits the ground, it's going to have a height of 0. So when is this equal to 0? We're just wanting to solve this. This doesn't look extremely factorable to me. Not that I know whether it's factorable or not, but I would maybe suggest let's try the quadratic formula to solve this. Now, one bit of advice, if you can make the number smaller, it may make life easier. And what I mean by that is possibly by factoring out a GCF. Let me write this down. So we're looking for when negative 16x squared minus 20x plus 180, we're looking for when it equals 0. Actually, can I just erase that? Okay. So that's all we're doing with these problems of asking when it's going to hit the ground. Now, I don't know off the top of my head of 180. I think it is. I believe all of these are divisible by 4. Let's get a calculator to be sure. So 180. Oh, yeah, we know that because of geometry. Divided by 4 is 45. So if I factor out a GCF of 4, I can have negative 4x squared minus 5x plus 45 and have a lot smaller numbers to deal with equals 0. Divide 4 over, it's out your way. Now we have a much simpler thing to work with. Okay, so let's label this. Negative 4 will be your A, negative 5 will be your B, and positive 45 will be your C. So once again, let me get some extra paper here. I'm going to go ahead and just do my quadratic formula. I'm going to do them both at the same time. So x equals the opposite of b. Well, b is already negative, so the opposite of negative 5 would be positive 5, plus or minus, or in our case, we're doing both at the same time, plus and minus. So b squared, negative 5 squared, I'm going to go ahead and do that. That's 25, minus 4 times a, which is negative 4, times c, oh, negative, there we go, times c, which is 45, all divided by 2 times a, which happens to be negative 4. So we can handle some of these pieces already. I know I have 5 plus or minus square root of something divided by negative 8. So let's go ahead and figure out what's going to be underneath the radical here. So 25 minus 4 times negative 4 times 45. Okay, so 25 minus 4 times, oh, I'm typing in the wrong thing. All right, let's try this again. 25 minus 4 times square root negative 4 close square root times, what was it, 45, I believe, equals 745. Let's make sure it was 45. Yes, it is. So I've already forgotten the number. I think it was 745, but let me go back and check it. I have too many things I'm thinking of right now. Yes, 745. Okay. So what we're going to want to do is 5 plus that divided by negative 8 and 5 minus that divided by negative 8. And we will get two solutions. So let's use the calculator to do that. So we'll go 5 plus the square root of 745. What I will do is put a parenthesis divided by, was it negative 8? Okay. And that gives us negative 4.0368. So if I round to two decimal places, there's the 3. Look, one passes. 6 is above 5. So negative 4.04. So there is one of the x's. All right, our next x. I need to do this, and instead of a plus, I need to subtract that. Boom, boom, boom. Let's just change this. I like this Desmond's calculator because I can easily go up and just change it. Boom. 2.7868. So if I round the second decimal place as an 8, the third decimal place is a 6, which tells me to round up. So 2.79. Okay. 2.79. All right. Now, I have two answers. Can there be two answers to this question? The answer is no. When is this thing going to hit the ground? Well, can I have negative 4 seconds? No, I'm not going back in time. We don't have a time machine. So how long will it take for this ball to hit the ground? 2.79 seconds. What's fun about this is this negative answer does have meaning if you do the rest of the parabola. It's back 4 seconds. It's just the back here, but literally time starts the second we throw the ball, so everything behind us throwing the ball does not exist in the context of this problem. So I throw out this negative answer, 2.79 seconds. So there we go. So interesting lesson, nothing more than plugging into a formula. And so we can plug into a formula to solve quadratics, whether it factors or not. You can get answers. You can get the exact solution. If it factors, you're going to get pretty solutions. If it doesn't, you're going to get irrational solutions with radicals. And then we could use it to solve word problems, and we may want to get